Okay, in this video, I'm going to run through the process of finding all the zeros, not just rational, but irrational. Little spoiler alert here, this video at the end will not just cover finding the easy ones, the nice ones from our P over Q list, but also irrational zeros. Okay, so this function is a fourth degree. So that means we could find up to 4 unique zeros for this thing. And let's get started by looking at the P over Q list that the rational zeros theorem says will give us a list of all the candidate zeros. So we're going to look at the factors of 18. I'm going to go parenthetically here and just go plus or minus 1, 2, 3, 6, 9, and 18. Think that's it. Yeah. So now let's look at the factors of 2, real big list, and that's plus or minus 1 and 2, smallest prime number. Okay, we need to simplify this. Our goal is to get the list of candidates, and right now all we have is a list divided by a list. So I'm going to divide everything in the top first by 1, so that'll give me plus or minus 1. I'll do this with the little parentheses again. So 1 divided by 1, 2 divided by 1, 3 divided by 1, 6, 9, 18. Okay, so we've taken care of those. And then the other one here, we'll divide everything by 2. So I'll get 1/2, 2 over 2, which is redundant, that's just 1, 3 over 2, 6 over 2, another repeat, that's just 3, 9 over 2, and last 18 over 2, which is just 9. We've already got that. Okay, so clean this up. One more little spiffy step here to get this to look like a nice thought out list. And this is the possible rational zeros. These are the candidates. If this function has any nice rational zeros, they will come from this list. It's not a guarantee that it does have nice rational zeros, but it is a sift to find them quicker if they do exist. Okay, so there's our list. Now step 2, we're going to run over to the graphing calculator. I don't have a great way of doing that on the iPad without being kind of awkward, so I prepared these ahead of time. If we're going to look and see which of these are actual zeros, we need to graph this thing. So I'm going to graph this function, and then using a trace feature, particularly what you'll see on my screen here is the TI-84 screenshots. All right, so enter that in your y equals and make sure everything looks good when you enter that. Now, with a little bit of window finding skill, I found that the best window was, or one of the better windows was -8 to +8 for your x-min and x-max, and then -325 for the y-min, the max of 50. I did change the scale so it wasn't so chunky on the y-axis. And I got a picture like this. Now again, this is a quartic, fourth degree, positive leading coefficient here. So this thing should be opening up and again can have maximum of 4 x-intercepts, 4 real zeros. Well, 4 complex zeros to be truthful, but in this case we do see 4 real zeros as x-intercepts. In other words, this is a dandy window to really get a look at where these values are. So I'm considering my list of values that we found in step 1, and which of those look like they're worth tracing. I can see right here on the left, it appears to be -6. So down below here, you'll see me trace to -6 and confirm that. And the other one, I believe, is +1/2. Trace to +1/2, that should trace out as well. This one and this one are not values from my list. So, look at the far right here. This is 1, 2, 3, 4. So something between 4 and 5. I've got nothing up here between 4 and 5. Something between 0 and -1. Well, I have -1/2, but I think I showed a screenshot of this. -1/2 just does not pan out. There it is. If I trace to -1/2, you could see that that's a dud. Okay, so here's the confirmation for 1/2, +1/2, and there's also -6. So step 3, as you saw in my previous video, if you've seen that, I guess, is to state the actual rational zeros. So the actual or verified rational zeros, the ones from our P over Q list that turned out to be zeros for real, these are at -6 and +1/2 here. Okay, so I'll remember that. That's part of the puzzle here that we're solving, which leaves us with 2 zeros we don't know. And one's negative, one's positive. So here's the process, and this is step 4. Now remember, since we have a 4th degree polynomial and we only found 2, which is less than the degree of the polynomial here, we only found 2 out of the 4 zeros, we need to do more. So what I'm going to do is divide these out. This is what our next step is, step 4, and then eventually solve for what we get after we divide. Keep in mind that if we have the actual rational zeros, then we could start building factors from those zeros. So just to give you a bird's eye view, we're looking for the chunk of this quartic polynomial. In fact, it's a quadratic chunk that we'll isolate using division. And we're going to solve that quadratic to find the 2 remaining zeros that we cannot locate with our P over Q list. So let's get started. So I'm going to first divide out the -6, and I'm going to use synthetic division to do that in a timely manner. Looks like we've got the terms lined up here. Don't need any placeholders because we've got all the terms we need. Drop the 2 down and get started with synthetic. Multiply by -6, we get -12. Add down, we get -9. And multiply by -6, 54. Add that down, we get -2. Multiply by -6 now, we get 12. Add that, we get 3. Multiply, add. And that is good. We get that last term, that's our remainder. So that's what we're hoping for. Did our algorithm correctly. And we're going to turn right around and divide by our other 0 now, which is the 1/2. So I call this iterative division because if you know 2 factors, you could take them out with division, one after the other. The order doesn't matter, and you'll be left with a 2-degree polynomial, a quadratic that we could solve. Drop the 2, multiply, we get 1/2 times 2 is 1. Add that to -9, we get -8. Multiply by 1/2, we get -4. Add that up, we get -6. And multiply, we get -3. Add to 0. And again, another little checkpoint here. That last number is our remainder, and we should be getting 0 as we are dividing out factors. So what this represents here is that quadratic factor I was talking about earlier, right up here. So this is 2x squared minus 8x minus 6. And we're actually trying to solve this. So we want to set it equal to 0 and find its zeros or its roots. Notice that there is a factor of 2 and everything. So I'm just going to let the air out of that one and divide the 2 off. So we've got just smaller coefficients to deal with. That's a fair move. And now, because I know the zeros, the roots I'm looking for are not rational, I am not going to waste time factoring this, okay? Do not factor when you're doing step 4 on these. What you want to do is go after this with the good old quadratic formula. So I like to set this up with empty containers and then fill in my A, B's, and C's and protect that order of operations as I clean things up here. Okay, so we'll start with our A value. Our A value is 1. That's going to go down here and in here. Then our B value of -4 pops in those first two blanks. And then C, the caboose, is -3. And then we can get to work on this. Let's go to the right here. So we get a double negative on that first 4. And I'm going to split this into two fractions. It's important to remember that that 2 times A value downstairs is underneath both chunks of what we're dealing with. So keep that 2 in play underneath both chunks. Going to the discriminant, we've got a 16 from the -4 squared. And you could certainly use your calculator to clean this up, but just be careful to use parentheses as I have demonstrated. All right, so this will further simplify to 2. 4 over 2 there reduces. You get a radical 28 over 2. And now remember, radical 28 is one of these radicals that we can break down into a factored form of radical 4 times radical 7, which is beneficial because radical 4 is just 2. So repack that over here, and what we see is still have that 2 out front. And then 28 was 2 radical 7. That up top with the 2 down below, we can now clean up that 2, reduce that out, and we've got 2 plus or minus radical 7. All right, now this is clearly irrational, and if you're confident and don't want to check, these are your 2 irrational zeros. But I'm going to go a step further and just show you how to verify that you've got these correct. And it doesn't take much time at all. I've prepared some screenshots here to show you what to do. Be mindful that this represents 2 plus radical 7. That's one of them. And 2, if you add, you get that one. If you subtract, you get 2 minus radical 7. So those are your 2 exact form irrational zeros. So if you're back in your grapher and you're hitting the trace button, okay, just below the screen there, the trace button, and then type it in just how you have it, 2 plus radical 7. What that'll give you is an exact trace to that x value where it's crossing the x-axis. Now, this is kind of goofy, and it happens sometimes on the TI-84, but just remember, this is round-off error. For all intents and purposes, 1.19 e -10. Well, that's just 1.19 times 10 to the -1 times 10 to the -10th, which is ridiculously tiny, and that's how we know, it's a round-off error. It's basically 0. So we're dealing with a messy irrational number, and the calculator, of course, approximates that out to a certain granular level, and sometimes it has round-off error. But if you check the other one, so 2 minus radical 7, you'll see that that goes exactly to 0 without any round-off error. And it's just kind of willy-nilly whether that happens or not on the calculator. Just feel free to interpret these as basically a 0 whenever you run into them. Okay, I hope that helps. I would take a second to go back and write my answers all together and say rational zeros at x equals -6 and positive 1/2, and irrational zeros, I'm going to abbreviate here for time, at x equals, 2 plus or minus radical 7. You can use the plus or minus to your advantage there and save some space. So we now have all 4 zeros. Some were nice, some were messy, and that's it. Thank you for